to our channel, My Tutors Online. We've been doing relations and functions actually, and last time we pretty much covered relations. Of course, I'll take just revision for 4-5 minutes, obviously, but we want to also do functions in detail because we haven't done it in the last class, and I hope you must have watched that last episode for relations, and today we want to continue functions, and also we want you to subscribe our channel, and boost our confidence. Also, we will be coming up with more and more topics, and we would be covering and we would be also doing this frequently because we know that sooner or later you will have to give exams also, so we would be doing that as well. For now, let's continue with our relation and functions, particularly functions, as we have covered relations. So I'll just say welcome, and yeah, we are good to go. Yes, so we would I'll just share my screen. Yeah, I hope the screen is visible to you. Yeah. Yes, good. So we so far we have seen relations, and I am going to take you through relation in just in 5 minutes. It's just we are going to just go through the basic relations, and we will just see quickly one example of relation, one quick example of relation, just to brush you up again, like last time, for the last session, in case you were not there, and we were quickly going to switch to functions. So I'll just quickly tell you what is relation. Relations are of three types. Relations are of three types. So one is transitive, symmetric, and transitive, symmetric, and reflexive. Yeah, so these are three functions. What is reflexive? Reflexive relation is for all a comma a belongs to R. Suppose 1 belongs to R, then I mean to say that, and so on and so forth. That is what is reflexive. What is symmetric? Symmetric is if AB belongs to R, that should also implies B comma A belongs to R. That is how it is. I repeat, if A comma B belongs to R, then B comma A belongs to R. Suppose AB belongs to R, BC belongs to R, then A comma C also belongs to R. If and then, that is the condition. So to say that A belongs to R, if then A comma A belongs to R is reflexive. AB belongs to R, BA belongs to, that is nothing but symmetric. AB belongs to R and BC belongs to R, then A comma C belongs to R can be written as transitive. And this is what is the relation. And if particular relation satisfies all these three, then we call it as equivalence relation. Then we call it equivalence relation. So that is what it is, and I hope this is clear. And I'm going to take you a quick example for the whether it is equivalence relation or not. So let A is equal to X belongs to Z, and 0 comma X less than 12. Yeah, then show that R belongs to A comma B, where A comma B belongs to A, mod A minus B is divisible by 4 closed is an equivalence relation, is an equivalence. That is the question. If A is a set of all numbers, all from 0 to 12, from 0 to 12, show that what we have to show, if A comma B belongs to set A, then mod of A minus B is divisible by 4. So that is the question. Yes. So suppose let's say A belongs to R. So for example, we should calculate for reflexive first. Actually, let's start with reflexive. A belongs to R, any number you take it. 4 belongs to R, let's say 4 belongs to R. So according to that, mod of A minus B will become mod of A minus B. Here it is A only, so it will become mod 0 is divisible by 4. Yes, 0 is divisible by any real number. 0 is divisible by any real number. Therefore, the relation is reflexive. Okay, let's go for symmetric. Let's go for symmetric relation. A comma B, we will have to take two numbers. So let's say I'm just going to say that 2 comma 4, let's see, belongs to R. Yes, 2 falls in the range of 0 comma 12. 4 also falls in the range of 0 comma 12. So yes, 2 comma 4 belongs to R. Then 4 comma 2 also belongs to R. Yeah, very much. Why? Because mod of 2 minus 4 is equal to mod 2 is divisible by 4. This is going to be 2 again, divisible by 4. And mod of 4 minus 2 is also going to be 2. So that is also going to be divisible by 4. Both are, going to give you. So A comma B belongs to R, then obviously B comma A is also going to be belongs to R, and therefore the relation is symmetric. So the relation is symmetric. So yeah, I should go for a transitive rather. Third one I'll do it. Now A comma B belongs to R, right? A comma B belongs to R. Let's take an example. Mod of A minus B is equal to 4. Let's say multiple of 4m. Let's assume that it is divisible by 4. So this can also be written as A minus B is equal to plus minus 4m. So A minus B is equal to plus minus 4m. So the division has to be multiple of, multiple of 4. Then only a mod of A minus B can be. Similarly, we will have to take one more, B comma C. Assume that B minus C is plus or minus. I'll just take this one screen up. Yeah, 4. So plus, not 4, plus or minus. I'll just take it as 4m. Assume that it is divisible by 4. Of course, I'll take the numbers and show you also. But for now, assume that B and C is there and A and B is there. So B and C is the multiple of 4, which means B minus C will be plus or minus 4. Now for this relation should be transitive, A minus C should belong. So A minus C should be belongs to, it should be divisible of 4m. Let's say I'll take x. Now you see, value of a is a minus c will become plus or minus 4x. Now if this comes as a 4 minus plus or minus 4x, then only it can be multiple of mm, 4. So a minus b plus b minus c. I'll write this as, please see carefully, a minus b plus b minus c. I'll write this can be, value of this can be plus or minus 4m plus or minus 4m, which means what? M plus n. So this also is a multiple of 4. So this can also be written as plus or minus 4m plus n, which means a minus c is also coming out to be multiple of 4. And if it is a multiple of 4, that means what? Therefore the relation is transitive. Therefore the relation is transitive, and we can say that the given relation is give me a minute. There was some technical error. Yeah, I hope it is good done. The given relation is equivalence relation. So if the function is having having a reflexive, symmetric, and transitive, all three relation, then the given relation is equivalence relation. So equivalence is nothing but it has all three, reflexive as well as symmetric as well as transitive also. This is to brush you up for relations, but our main goal is to functions. Before I go into types of it and all, I want to understand what is basically a function. So function means we directly go for f of x. So what is f of x? Let's say it is x square. And let's say if it is in the variable term, then we write it as y equal to x square. That is what we get idea as a function. Before you go into types, this is extremely important to understand. X and y are any two variables. X and y are any two variables. So I will take x as 4, let's say. What happens? Y will become y will become 16. So for every real value of x, y gives some value, right? Y will give some value, and for some values, and at some values, x will have the some values of y, x will have some other values. So for every real value of x, y will also have some value. Every value of y, x will also have some value. This is the function. If there is if there are more than one variable, and one variable having a real values also gives the real value of another value or another variable, here it is y. If that is what is happening, then it is called a function. Now for same value, it can have, for same value of x, it is possible that y can have a same value. For example, if x is -1 and x is equal to 1, for both these values of x, y has the same value. What will be the value of y in this case? 1. In this case, 1. So it is possible that for many values of x, y can have the same value. Or is it also possible that x for same value of y, x has a different? Of course, that can also possible. For example, if this is the case, y is 4 and x square is 4, x can have 2 also. Same thing for the same value of x, for the same value of y, x can have another value. So what I'm trying to say here is that in functions, one thing is very clear. If it is a real value for one variable, there also should be another set of real values for another variable. This leads us to two terms, namely range and codomain. Range and codomain. So this is what is the indication. Then this, whatever the set in B is, it is nothing but range. This is nothing but codomain. And based on whether codomain is equal to range or whether it is not equal to, or whether codomain is a subset of range is a subset of codomain, based on all these combinations and permutations, it is decided whether the function is 1 1, whether the function is many 1, or whether the function is 1 2 into, and so on and so forth. Before I go to that, let me give a simple example. Right now, I am teaching you to many students right now. How many are there in online, and I am only the teacher, and there are many students, right? There are many students. So we are like many one. So there are many students, and there is only one particular teacher. So we are currently many one. So for one particular variable x, there can be have multiple values of y. In this case, it is a many one. So how to represent this graphically? Very simple. Suppose this is a b, then it is you can call this as a many one. Point here is not whether it is many one or 1 1. 1 1, how you will show it? Simply like this. For each value of set A, B also has some value. This is called as 1 1 function, and many one and it. So we will see that very clearly, many one and 1 1. So let's take it like this. We will do 1 1, right? And another is onto, then it is not 1 1, and there is a not onto. What is the 1 1 function? For a equal to b, it is f of a equal to f of b. For a equal to b, so here also one function is there here. So this is called as 1 1. What is onto function? What is onto function? How will you indicate that? Graphically. This is called as onto function, or you can say like this. So it is a, b, c, d, and this is onto. So for many values of codomain, range has only one value. So basically codomain is a subset of. So in this case, it is onto. What is here? Here the range will be subset of codomain. Then it is not onto. I repeat, when the range is a subset of codomain, it is not onto. And when the codomain is a subset, it is a onto. What is 1 1 function? For each value of set A, there is some value present in set B. I'll just take one example for you. Just give me a minute. So I'll just draw the diagram. You will have to say whether the function is 1 1 or not. Now if I have to write it in set, it will look like this. Here, if I take variables, it will be like this. For each distinct value of x, there is a distinct value of y. If this is the case, then it is 1 1. But if there is a case like this, 1 comma A, 1 comma B also, 1 comma. Now for each value of there are some values in X where there is no a value of for B in set B, and there are some values in A, that means for which there is no value of B here. Here the codomain is only 1. Codomain is 1, and if you see range, it is A comma B. If this is the case, it is not 1 1. This is not 1 1 function. I hope you are able to spot the difference here. What is codomain and what codomain is the values which the set A are there, which X takes basically. If X is the first variable, the values which X takes are codomain. The values which we get after substitute that is a range. Here the range is A comma B comma C. Codomain is 1, and for each codomain, if there is a value here in B, it is 1 1. If that is not the case, it is not 1 1. I hope that is clear to you, and you can also, meanwhile, you can also type down your doubts, or if you have some questions, we will soon answer it in the chat sections. You can also write the questions, and also we would like to answer it as and when you get the questions. Yes, one of the thing is I'll give another example now. You just have to identify the function onto or not onto. Onto is, I repeat, onto is a function in where the codomain is a subset of it. Not onto is a function where the range is a subset of codomain. If the range is a subset of codomain, it is not onto. So I'll just take a onto. For onto, I'll tell you the representation. F of X is equal to Y for every Y belongs to R, such that F of X is equal to Y. If this is the case, for every Y belongs to R, if this is the relation A comma B, and this is the function A is to B, for this relation, if such that F of X is equal to Y, if that is the case, then it is onto. Onto can be represented like this. Yeah, this can be onto, because for each value of X, there is, for every Y in R, there is a F of X is equal to Y. So for each value, if it is there, that is onto. What is not onto? What is not onto? Not onto is nothing but where the range is subset of code. So for example, the range for B is A, B, C, D. Now range for this function is A, B, C, D, and the function is indicated like this, and one of the function is given like this, and the function is like this, and there is no value for C, there is no value for D, there is no value for D, then in this case it is not onto. In this case it is not onto. But suppose the range is given as for B is A, B, C, D, and for each A there is some value here. Okay, it is 2. For B also it can be 2. C, let's say it is 3. For D, let's say it is 1. If this is the case, the range is as it is A, B, C, D, this is onto. Because for every Y in relation, there is a f of x. For every y, there is a f of x. This is f of x and this is what. For every y, there is some value here, some value in set B. For every value of y, there is some value in f of x, that is a. So in essence, what I'm trying to say, I'll just tell you in one word now. Maybe it was very confusing to you. I am trying to say for each value of y, there is f of x. For each value of y, there is some value present in f of x. It is possible for that for two values of y, there is only one f of x. It is possible. There is no problem. I am only concerned about only one thing. What is that? For all the values of y, let's say there are four values of y. There are subsequent values in f of x that is in set A? That is the case. It is on 2. If not, that is not on 2. If not, that is not on 2. So this is all about not on 2. What is many one? Okay, so 1 is done. 1 is very simple. For each value of y, there is a distinct value x. In onto, it doesn't matter whether it is distinct value of f of x or not. It all matters that for each y, there is f of x or not. I am saying many one. Many one. What is many one? What is many one? If there is one x and there are multiple values, for example, now x, y, z, it is 7, 8, 9. So the one and so many one function is this. Many one. So where the 7 is, so if the range is like the original range is 7, 8, 9, and here the range is only 7. In this such a cases, it is many one. If not, then it is onto or one. So there are three types. Many one is there, onto is there, and one is there. I hope this was clear, and also you got some idea of relations. So there are three types of relations also: reflexive, transitive, and symmetric. There are three types of functions also: one, onto, not onto. That is into also. It's called into also, onto, into, and many one. So there are four if you want to say. So onto, into, and many one. So these are four types of functions we have. As you saw, as we will solve more examples, you will come to know it. So thank you for being with us. Please subscribe to our channel. It's My Tutors Online, Habjain Educational Service Private Limited. I have been personally teaching here since last 1 year, and it's a wonderful platform. And you can also call, there is a number given here, 9871542883. You can also call it on it, and please subscribe to our channel, and we hope that we are able to help you in becoming expert in solving maths problems. Particularly to speak on relations and functions, you need to become expert in some theoretical concepts as well. And yes, so please subscribe now to our viewer goal. We also have other sessions also running for chemistry as well, and you can join that too also. Yeah, and yes, for any inquiry there is a number also given. So yes, you can always call. I'm just giving you that number here also. Yeah, so that one is also there. You can also have call here and get the advantage of it. Yeah, so you can always call that. I'll just yeah, so on the screen you can see that number. By mistake I have typed it wrong. I'll just type it again for you. 987154. Yeah. I hope if you can see on the screen. Yes, so that's the, we have, and you can always contact if you want coaching for particular problem. And yes, we will be there to help you also. And yes, please drop down your suggestions here, because actually we want to make it very interactive also. And because more and more you will ask us questions, better and better content we can make. And we will be very happy if you subscribe to our channel. And thank you very much for joining with us. Yeah, thank you.